Hello everyone! In this class, we will learn about the composition, grid connection forms, and related technologies of wind farms. Compared with conventional large thermal power plants and hydropower stations connected to the grid, the wind farms have the characteristics of small unit capacity, low AC side voltage level, and a variety of unit types and quantities. For example, the single unit capacity of the current mainstream wind turbine is generally between 1.5 and 3 megawatts. And the typical AC side voltage level is 690 voltage. There are often dozens to hundreds of units of inverters in a wind farm, so their connection to the grid is very different from the conventional power plants. The wind farms can adopt typical connection methods, such as distributed access, centralized access, and cluster access, based on their size, location, and public grid conditions. Distributed access refers to several wind turbines, boosting to 1035 kilowatts through a unit transformer and directly connecting to the system through a 1035 kilowatts feeder. The 1035 kilowatts busbar of the substation is shown in Figure 3-1, and this connection method is generally suitable for smaller wind farms within 20 megawatts. Centralized access refers to the process where the wind turbines are boosted to 1035 kilowatts through a unit transformer and then gathered at a step-up substation through a 1035 kilowatts collection line. They are then boosted to 66 to 330 kilowatts and connected to the 66 to 330 kilowatts busbar of the system substation through a 66 to 330 kilowatts transmission line. This connection method is suitable for larger wind farms, ranging from 50 to 300 megawatts. Cluster access refers to multiple wind farms that are centrally connected to the 500, 750 kilowatt substation busbar through a 330, 500, 750 kilowatts connection station. This connection method is commonly found in large-scale wind power bases, such as those in Gansu, Inner Mongolia, Hebei, Jilin, and other regions in China. The figure shows the collection and connection methods of some wind power clusters in Jiuquan, Gansu, China. The grid connection operation of the wind farms will have a significant impact on the power grid. The figure shows the daily output curve of a wind farm in Gansu province, China. As can be seen from the figure, first, the grid connection of wind farms will affect the stability and safety of the power grid. After the wind farm is connected to the power grid, the output of the wind farm will fluctuate greatly, affecting the frequency, voltage, and power angle of the power grid, leading to a decrease in the stability of the power grid, and may even cause oscillations in the power grid and power grid faults. Therefore, it is necessary to strengthen the interaction research between the wind farms and the power grid, develop the reasonable dispatching strategies to ensure the safe and stable operation of the power grid. Various faults and abnormal situations may occur during the grid-connected operation of wind farms. The faults and abnormal situations during the grid-connected operation of wind farms include wind turbine faults, transformer faults, transmission line faults, etc. These faults and abnormal situations may pose a serious threat to the stability and safety of the power grid. Second, at the same time, the grid connection of wind farms will also have a huge impact on the dispatching and operation of the power grid. After the grid connection of wind farms, The output fluctuations of wind farms are large, posing challenges to the grid dispatching. It is necessary to strengthen the dispatching ability of the power grid, improve the flexibility of the power grid, and respond to the output fluctuations of wind farms. The grid connection strategy is a key technology to ensure the stable operation, safety, and interconnection of wind farms with the power grid. The response strategies for the grid connections of wind farms include improving the forecasting system of the wind farm, improving the accuracy of wind farm prediction, strengthening the flexibility construction of the power grid, and improving the grid's ability to regulate the output fluctuation of the wind power, such as fixed speed control, variable speed control, mixed speed control, active power control, reactive power control, and voltage control. Developing the energy storage technology and utilizing the energy storage system to compensate for the shortcomings of the output fluctuations of the wind power. As different grid connection strategies have their own advantages and disadvantages, the wind farms should choose appropriate grid connection strategies based on their own characteristics. The grid connection technology of the wind farm is constantly advancing, with the development of wind power industry from early fixed-speed wind turbines to current variable speed wind turbines, from reactive power compensation devices to active power control devices. It is constantly improving. The current development trend of the grid connection technology of the wind farm is intelligence and digitization, using intelligent control technology and digital technology to achieve the intelligent operation and digital management of wind farms. The application of energy storage technology in the grid connection technology of the wind farm is becoming more and more widespread. The use of energy storage technology can smooth the output fluctuations of the wind farm and improve the grid connection ability of wind farms. In this lesson, we learn about the composition, grid connection forms, and related technologies of wind farms. That's all. Thank you.